Hey, what's up, folks? How's it going? So today we'll go through a couple of questions, and these questions I have seen it's coming in interviews. Not all of them are that much popular, but few of them I have seen they are coming in the interview. So I thought like let's create a one miscellaneous section where I put all these interview questions, and I have already covered many interview questions. You can have a look at my Terraform playlist. So there you will find a lot of popular interview questions. So let's go through these questions one by one. The first question is when you need to use Terraform init upgrade. So Terraform init, when do you use it? Terraform init basically like you start, you create a folder, write some script, you do Terraform init, then apply, and then plan and apply. Right? So init, what happens? You are dependent on some provider like AWS provider. So when you're doing Terraform init, it is downloading that provider, AWS provider, or that plugin, right? So it is downloading that. So when you want to update the provider, you want to do this Terraform init minus upgrade. So when you want to upgrade the provider, you want to update the provider when there is a version conflict. Your Terraform complains about outdated or incompatible provider version. Or there are some plugin updates like when switching between Terraform versions or updating dependencies. Or there are some remote backend changes which requires update for compatibility. Or there are major Terraform upgrade and you want to update the Terraform, all the plugins, right, all the providers, etc. Now let's go to the next question. Next question is Terraform versus TerraGrant. Which one should you use? Right? If you go to a Grant website, you can see that it's a follows dry principle and maintainable open tofu Terraform code. TerraGrant is a flexible orchestration tool that allows infrastructure as code to scale. Okay. So when you want to use Terraform, when you want direct control over infrastructure as code, simplicity and native Terraform workflow is preferred, and you have a small medium-sized infrastructure. So direct control you want small and medium-sized infrastructure, and you want a native Terraform workflow. But use Terra Grant when you need to manage multiple Terraform modules efficiently, and you want to follow this principle dry. That is, do not don't repeat yourself principle. Means you want to reduce the code duplication and enforce best practices. Okay, and you require easier state and dependency management across environments. Version control for Terraform modules. Terragram supports multiple versions of Terraform modules per environment. For example, in prod, you can use version 1.0. In staging, you can use version 2.0 of VPC module. So different version you can use in different environment. It ensures immutable infrastructure, making rollbacks and tracking easier compared to Terraform. And Terraform Workspace don't support versioning. But here you can have that kind of versioning kind of thing. Visibility, Terraform workspaces are hidden. It's not visible. Terraform workspace, you need to run the command Terraform workspace list, then only you'll be able to see it. But Terragrant uses files and folders. So you will be able to see it's visible. You will see that there's a folder for dev, stage, prod, and directories are there. And there are like a live repo layout clearly shows dev, stage, prod. But in Terraform, it's not a direct structure. It's a Terraform workspace list to know the existing environment. So visibility is another thing, visibility of the environment. And reducing environment switching error. Terraform workspace switching is manual. You switch Terraform workspace select. So it's easy to mistakenly destroy prod when thinking you're in dev. So you are maybe in prod and you may say destroy. So there is a chance of doing that. But Terragrant avoids this by structuring environment in separate folder. So you will be able to clearly visible. It will be see that you are in dev folder or you are under slash prod folder. So it's clearly visible. And when you, before running Terraform destroy, you'll be able to see that you are running under prod. So you won't do that, right? So if you're in a prod, it's clear that you are working on production. So that is another thing, reducing environment switching errors. So they are the main reasons: visibility, reducing environment switching errors, multiple version support of the module. For that, you want to use a Terraform, a Terragrant. Okay, next question is what is idempotent in terms of IAC, infrastructure as code? This we already discussed in one of our video earlier in the playlist, Terraform playlist, you can see. So idempotent is provided by infrastructure as a tool ensures that if the same code is applied multiple times, results remain same. Suppose you are creating EC2 instance or S3 bucket, and that is your desired state. You already created, and Next time if you do Terraform apply, it's not going to create that again, or it's not going to throw error, right? And that's called idempotent. But in normally what happens, you got say you're executing make directory. It's creating directory. Again, you're executing it. It will throw error. The directory already exists. But here that kind of thing won't happen because it compares reserved state and actual state. Both are same. It won't do anything. So it will like it will if you, even if you apply the same thing multiple again and again, results remains the same. Next question is, you want to create a parallel distinct copy of a set of infrastructure in order to test a set of changes before modifying the main production infrastructure. So you have a main production infrastructure and you want to test out some changes. You can't do on production and you want to quickly do that. How do you achieve that? So you can achieve this by creating a separate workspace in Terraform or using a different backend environment. Okay. So these are the things like you can use Terraform workspace. Next question is, how can you define multiple providers for different regions with the same configuration file? In the same configuration file, you want to define multiple providers. This we already discussed in one of our playlist as part of some other question, but let's go through this again. So by aliasing provider, you can do that in Terraform. Here, provider AWS. Here we have created alias get waste. So in when we are creating the resource, we can say AWS dot waste. So using this alias name, we can do that. Multiple providers. For different regions. Allies. We can use allies. So you can subscribe to my follow my LinkedIn page where I post daily quiz question. So here you can see that provider AWS, but here provider equal to AWS.waste. So in AWS West, this instance will be launched. This resource AWS instance will be created. Waste instance and this. How do display dependency graph in Terraform? We have already discussed this. So this is the common. We have discussed this in detail. I've shown you also some examples. How do you generate a human readable execution plan? Terraform plan minus out file. Terraform plan minus out. So we are outputting this Terraform plan. Terraform plan minus out file. Next question is Pulumi versus Terraform. So what is the difference between Pulumi versus Terraform? So we can see here they have nicely mentioned Terraform versus Pulumi. So Pulumi and Terraform are both infrastructure as code technologies that have similarities but many fundamental differences. Pulumi is open source, offers the flexibility to use any programming language for managing infrastructure, right? But Terraform requires a proprietary domain-specific language (DSL), right? In this comprehensive guide, we'll explore the key differences. Pulumi is an open source infrastructure as a code. Terraform provides infrastructure as code software for cloud service management with a CLI workflow. Terraform allows you to write, plan, apply changes to deliver infrastructure as code. So let's see the differences. Here, license, it's a Pulumi Apache license. Here, there's no open source license, it's a business license. Language support Pulumi, Python, TypeScript, JavaScript, Go, C Sharp, like Java, YML, all this, it supports, it only supports. Terraform only supports HashiCorp configuration language, HCL. ID support, it supports ID, code completion, strong typing error, so again, let's resource documentation, etc. But here it's limited. State management, managed mainly through Pulumi Cloud by default, self-managed option available. Here, self-managed by default, managed SaaS software as a service option available, like Terraform Cloud. Provider support, native cloud providers with 100% same-day resource coverage and turnkey access to Terraform, any providers. Support across, there's also having cloud native support, traditionally typed, including CRD, cluster operator for GitOps delivery. Okay. Dynamic provider support. This has a support. It has a support. It doesn't have support. So these are the things you can have a look at it. Policy at code. These are all it's having. Analysis. It is having here. It's limited. It's there, but it's limited. Audit capabilities. It's available. Here also it's limited. In Terraform Cloud, you will have any audit capabilities, but normal Terraform you won't have any audit capabilities. Adopt existing resources. Yes, generate code as part of the input process. Here, no code generation capabilities. It's possible that you can import it, but all the attributes, etc., you have to manually add it. Okay. Import code from other IIC tools. You can import from other ISC tools like CloudFormation or Terraform. You can import or something, but here it's not possible. So the other things you can have a look at it. You can read this documentation. A lot of information available. This question also sometimes people ask. Yeah, not very common, but yeah, people may ask it. Then the next question is where will you use Terraform and where will you use Ansible? So basically, the difference between Terraform and Ansible. What is the difference between Ansible? So Terraform is a declarative provisioning. So Terraform is a declarative. You say that I want this, I want this. It declare it, right? So provision infrastructure is good. AWS, Azure, GCP. You define the desired state, and Terraform ensures it happens. You say that I want this, and Terraform will make sure that it's happening. Use cases will be like creating virtual machines, network databases, managing cloud infrastructure, state management, maintains a state file to track infrastructure changes, immutable infrastructure. Ansible is imperative configuration management. Ansible is a imperative configuration management. So you define step by step. This step, follow this step, install it, then do this configuration changes, right? So it's an imperative. And use cases installing software, patching, configurations, or configuring server. So you can do Terraform. You can create a AWS infrastructure, right? EC2 instance, S3 bucket, etc. And EC2 instance, if you want to install some software, patching, and etc., you can do Apache, this Ansible. Deploying applications on existing server, automatic system administration task, right? It's agentless, SSH instead of requiring agents. Immutable infrastructure modifies running instances rather than replacing them. But Terraform is immutable, and this is a mutable. So which one to use? Terraform for infrastructure provisioning and Ansible 2 for configuration management. Terraform, you create the infrastructure, virtual machines, network, etc. And Ansible, you install the software, managing users, so for configuration management. And use both together, Terraform provisions, and Ansible configures. Terraform provisions, Ansible configures. So why not Ansible for cloud provision, etc.? Because there is no state management. Unlike Terraform, Ansible doesn't track the state of infrastructure. If something is already deployed, Ansible doesn't know unless you manually check. Procedural execution, Ansible runs tasks in order, but doesn't innately ensure that in final infrastructure matches the desired state. Right? Like imperative, it's not declarative. Difficult rollback. If something goes wrong, rolling back to the previous infrastructure is not straightforward. So no state management, procedural execution one after another, and difficult to roll back. Three things: no state management, procedural execution, and difficult to roll back. Why Terraform is better? State management is there. Declarative approach to define the desired state once, and Terraform ensures infrastructure matches it. And rollback is better. If an issue occurs, Terraform lets you revert to the last working state. So Ansible is great for configuration management, but when it comes to infrastructure as a code, Terraform is much better. So Terraform for provision and Ansible for configuration. Okay. So that's it for today. Hope you like the video. Please subscribe my YouTube channel. Follow my LinkedIn page. There I post a daily quiz and organize contests also sometimes. And also follow my WhatsApp channel, Devops Challenge Hub. And you will find resources like links in the down below or on my LinkedIn page. And on the links you will find them. Thank you for watching.